Hello everyone, I am Kiran from Sri Venkateswara College of Engineering, Bengaluru. Today I am going to discuss one of the topic in mathematics for engineers, that is Markov chain and Fourier rectangular series. Introduction to Markov chain and Fourier rectangular series. Markov chain is a mathematical model that represents a sequence of events where the probability of each event depends only on the state of previous event. Fourier rectangular series is a mathematical tool used to represent periodic functions as a sum of sine and cosine functions with different frequencies and amplitudes. Both Markov chain and Fourier rectangular series have applications in various fields of engineering such as signal processing, control system, and communication system. Markov chain fundamentals. Markov chain consists of a set of states and a transition matrix that represents the probabilities of moving from one state to another. The transition matrix is a square matrix where each element represents the probability of transition from one state to another. Markov chain can be classified as discrete time or continuous time depending on the nature of events being modeled. Markov chain applications. Markov chain are widely used in engineering for modeling various real-world scenarios such as queuing system, inventory management, and reliability analysis. In queuing system, Markov chain can be used to analyze the performance matrices such as average waiting time and system utilization. Markov chain are also used in reliability analysis to study the behavior of system over time and predict the probability of system failure. Now, there are some applications of Markov chain in real world. They are used in biology, probability theory, testing, and finance. Fourier rectangular series fundamentals. Fourier rectangular series is a mathematical representation of a periodic function using a sum of sine and cosine functions. The Fourier series coefficient represents the amplitude and phases of the sine and cosine functions that make up the periodic function. The Fourier rectangular series can be accurately approximate a periodic function with a finite number of terms. Now formula for the Fourier series is f of x is equal to 1 by 2 a naught plus summation from n equal to 1 to infinity an cos nx plus summation from n equal to 1 to infinity bn sin nx, where a naught is equal to 1 by pi integral limits varies from minus infinity to minus pi to plus phi f of x dx. An is equal to 1 by pi integral limits varies from minus pi to plus pi f of x cos x nx dx. Bn is equal to 1 by pi integral varies from minus pi to plus pi f of x sin nx dx, where n is equals to 1, 2, 3, 4, so on. Fourier rectangular series coefficients. The computation of Fourier rectangular series coefficient involve calculate the integrals of the periodic function multiplied by a sine and cosine functions. The coefficient determine the amplitude and phase of each sine and cosine function in the Fourier series. The Fourier coefficient can be used to reconstruct the original periodic function. The formula is f of x equal to 1 by 2 a naught plus summation n equal to 1 to infinity a n cos x nx plus summation from n equal to 1 to infinity bn sin nx. Fourier rectangular series application. Fourier rectangular series has a numerous application in engineering such as signal analysis, image compression, and control system. In signal analysis, Fourier series can reveal the frequency content of a signal and help in filtering out unwanted noise. In image compression, Fourier series can be used to represent image in a compact form by removing redundant information. Markov chain limitations. Markov chain assumes that the future state depends only on the current state, which may not always hold true or real-world scenario. Markov chain can become computationally complex for large systems with a large number of states and transitions. Markov chains are based on assumption of scenario process which may not be realistic for some applications. Fourier rectangular series limitation. Fourier rectangular series can only represent periodic functions and it may not accurately approximately non-periodic functions. The accuracy of a Fourier series approximation depends on the number of terms used in the series. Fourier series may introduce Gibbs phenomenon, which is overshoot or understood of a Fourier approximation near discontinuous. Conclusion. Markov chain and Fourier rectangular series are powerful mathematical tools used in engineering mathematics. Markov chains are useful for modeling sequential events and analyzing the behavior in various engineering applications. Fourier rectangular series are valuable for representing periodic functions and analyzing their frequency content in engineering applications. Thank you. Thank you for watching this video.